Hello and welcome to the second video in our 1.04 series. This is Physical and Chemical Changes. I'm Mrs. Willie and let's get going. Changes are acts of making or becoming something different. Changes of matter fit into two categories. Physical, which is a change that does not involve the change to the identity of a substance. So that could mean cutting, breaking, filtering, smashing, freezing, melting. Those are all changes that do not change the composition or the identity of a substance. Chemical changes are a change when one or more substances are converted into one or more different substances. In other words, when chemical bonds break or form or both. Chemical changes have specific evidence that lets you know that they're occurring. So, an unexpected color change. An example of this is in a precipitation reaction. I mix two aqueous solutions together and I get a bright yellow solid that occurs. That would be an unexpected color change. Adding food coloring to water would not be an unexpected color change because I know the food coloring already has a color, so it will change. So that's what I mean by unexpected color change. Gas production, which is I can actually see bubbles forming inside my two samples when I mix them together, or when an unexpected smell is produced. So some gases have a really awful odor that comes along with them. So that would also be an unexpected smell, and that would show you that gas is being produced. Light production and unexpected light production. So an example of that would be lightning bugs. When you're sitting down here in the south and you look out into your yard and you see flecks of light, that is a chemical change that is happening. Also, the glow sticks, when I break them, the two solutions mix together and a change occurs. An unexpected temperature change. So I mix my two solutions together and the beaker gets warm or the beaker gets cold. That would be an unexpected example. Melting would mean I'm already increasing the temperature, so I know that it's going to get warmer, the sample. Or if I put it in a freezer, I'm lowering the temperature, so I know the sample is going to get cooler. So that would be an expected temperature change. What we're talking about is the first part, where an unexpected temperature change happens. And precipitate formation, which is a solid formation. So in my first example, when I mix two beakers together and a bright colored precipitate or a white precipitate is formed, it is a solid. So the way that I remember this is the acronym City Geologists Love Their Silent Phones. This will help you to remember the evidence of a chemical change. Physical changes, again, were the changes that don't change the makeup of the identity of the composition of what I'm talking about. In the last one, those compositions do change. In chemical changes, they do change. Chemical bonds were being broken and formed. Here, that's not happening. So all changes of phase are physical changes. So like I said, I'm increasing the kinetic energy of a system. And so my sample is absorbing energy, or I'm decreasing the kinetic energy. I'm lowering the temperature, and my sample therefore changes phase. These are all physical changes. So a solid going to a liquid would be melting, or a liquid going to solid would be freezing. So in melting, I am absorbing energy. In freezing, I am releasing it. A liquid going to a gas would be vaporization or evaporation, and gas going to a liquid would be condensation. This is those liquid droplets that are on the side of your glass. This is going from a more excited state to a less excited state. Therefore, it is releasing energy. This is going from a less excited state or less energetic state to a more excited or more energetic state. Therefore, it is absorbing energy. Gas to a solid. So I have a gas straight to a solid would be called deposition. And then solid straight to a gas would be sublimation. Examples of deposition could be snow. I'm going straight from a gas to a solid. An example of sublimation would be in CO2 or dry ice, a solid going straight to gas. So as a substance changes from a solid to a gas, energy has to be absorbed. This applied energy is used to make particles move faster. So this is kinetic energy. This makes the temperature increase. When the solid substance has reached its melting point, additional absorbed energy breaks interparticular attraction. Remember, we talked about how these have strong attraction, so that a kinetic energy is allowing them to have more movement. And as they melt, so when they are in this phase change, they are in equilibrium with each other. They are increasing in potential energy. It's drawing on that stored energy to get from the solid to the liquid phase. Phase changes the opposite direction would release energy instead of absorb it. So as I'm going from the liquid to the solid, I would release energy. Releasing kinetic energy, then here releasing some of that stored potential energy to settle into a solid. Phase changes can also be written H2O solid, arrow, H2O liquid. So this kind of looks like a chemical formula or equation that you've seen before. But notice the pure substance is not changing. It's staying the same. It's just those state signifiers that are changing from a solid to a liquid. Thank you for watching. See you next video.